let's get started here. Okay, what we want is the derivative of a logarithm. So we've got y equals log base a of x. Log base a of x? Forgot what that meant. It basically means that we're taking the log base anything of x, and we're trying to take the derivative of that. So how do we do it? Well, we know how to do the derivative of an exponential, so why don't we change the logarithm into an exponential? How do we do that? We need the cha-cha-cha.
Cha-cha real smooth. Turn it up.
A to the y equals x. A to the y equals x. Okay then. So here we go. A to the y, oops. We'll edit that out. A to the y equals x. All right, now we're going to take the derivative implicitly. So the derivative of a to the y, well, remember, the derivative of e to the y would be e to the y. The derivative of a to the y is going to be a to the y natural log a. And then, don't forget, we have the chain rule. Oops, wrong thing. We have the chain rule. Okay, so notice, y is a function. So that means I better multiply by the derivative of y. So we've got the derivative of a to the y is a to the y times natural log of the base times the derivative of the inside of this function, which is dy dx, equals the derivative of x, which is just 1. Okay, now all we have to do is get dy dx by itself, and we're in the money. So basically divide out the a to the y natural log a, so we have dy dx equals 1 over a to the y natural log a. Now, another way we could say this is, it's just 1 over a to the y times 1 over natural log a. Because basically, if we take the derivative of a to the x, we get a to the x natural log a. If we take the derivative of the inverse of that, then instead of multiplying by natural log a, we're going to be dividing by natural log of a. So now, what if we have, instead of y equals log base a of x, what if we have y equals log base e of x? Then dy dx is going to equal 1 over e. Wait, something has gone wrong. Oh, I'm not finished yet. Okay, notice we don't want 1 over a to the y. We want to know what y is. Well, y equals log base a of x, or what I could say is a to the y equals x. So that means this equals 1 over x times 1 over natural log a. Okay, so this is what we really want, is 1 over x times 1 over natural log a. So now, if we go down to the derivative of natural log x, that's going to end up being 1 over x times 1 over natural log e. Well, natural log e is just 1, so this just becomes 1 over x. All right, so I've told you before, in calculus, the main type of logarithm we're going to be working with is natural log. So when you want the derivative of natural log, that's just 1 over x. When you want the derivative of log base a of x, it's going to be 1 over x times 1 over natural log of the base. So that's the key thing that we have to understand for this coming chapter, or this coming section. Okay, next example. Y equals natural log of the quantity x cubed plus 1. So what's dy dx? Well, it's natural log, so we don't have to worry about the 1 over log base a. So what we do is we say dy dx is going to equal 1 over, oh no, it's in red, how embarrassing. Dy dx is going to be 1 over the x cubed plus 1. Now, remember, this is not just natural log of x though. This is natural log of a function. So clearly, we need the chain rule. Okay, so we need the derivative of the inside, which is now 3x squared. All right, that's it, game over. So we could clean this up and just say dy dx equals 3x squared over x cubed plus 1. All right, try another one. Y equals natural log of sine x. So, dy dx, 1 over sine x. And of course, the chain rule. Okay, so 1 over sine x times the derivative of sine x, which is going to be cosine x. And that's it. So if we clean this up, cosine over sine is cotangent x. That's it. Game over. Okay. Next, we have natural log of the square root of x. So, natural log of the square root of x, the derivative is going to be 1 over the square root of x. Pretty simple. But what have we forgotten? Okay, the derivative of the square root of x is 1/2 x to the negative 1/2. Okay, so we need to just clean this up. So we've got 1 over the square root of x times 1 over 2 square root of x. Notice this ends up being on the bottom, square root of x times square root of x is just x, and 1 times 2 is 2, so it becomes 1 over 2x. Bam! That's it. Game over. Okay, now, let's check out f of x equals log of the quantity 2 plus sine x. So f prime of x is just going to be 1 over that. So 1 over 2 plus sine x. And then, of course, the derivative of 2 plus sine x is 0 plus cosine x. And so f prime of x is going to equal cosine x over 2 plus sine x. Now remember, if we have a fraction with an addition in the numerator, you could split that up into 2 fractions. The fraction with the addition in the denominator, you cannot split this up. This does not equal cosine over 2 plus cosine over sine. No. So that's as simple as we can get this. All right, so you're getting the hang of it. It's basically the derivative of a log function is going to be 1 over that thing. And then if you have a function there, you have to take the derivative of the function. Now, up until this point, we've been using all natural logs. Oh, yeah, we have one more natural log function here. So, check this out. Natural log of x plus 1 over square root of x minus 2. So, the derivative is going to be 1 over x plus 1 over square root of x minus 2 times the derivative of the inside. Let's not take up that much room. Times the derivative of the inside, which is the derivative of this whole fraction. So how do we do that? Well, we've got low d high minus high d low. Now, d low is going to be, remember you have the x minus 2 to the 1/2 power, so we've got 1/2 times x minus 2 to the negative 1/2 power. So here we are, low d high minus high d low. Now notice x minus 2, the chain rule would just make it times 1. And then we need to square the bottom, and away we go. So the square of the square root is just going to be x minus 2. Okay, now, first thing we can do, this 1 over this mess, all we have to do is reciprocate that mess. So this is going to equal the square root of x minus 2 times, let's see, what can we do with this? Yeah, let's just do this. Square root of x minus 2 for x plus 1 times, now the top is going to be the square root of x minus 2 minus, now it's going to be x plus 1 over 2 square root of x minus 2, all divided by x minus 2. Now notice the x plus 1 here is on top, the 2, the 1/2 makes a 2 on the bottom, and x minus 2, the negative 1/2 becomes square root of x minus 2 on the bottom. Now we can get common denominators between these two and multiply together. Basically, it's just algebra at this point, but let's go ahead and do the algebra. So we've got square root of x minus 2 times, now if I make the common denominator actually 2 square root of x minus 2, so 2 times square root of x minus 2, so I have to multiply the top by 2 square root of x minus 2, so this becomes 2 times x minus 2, and then this is minus x plus 1, all divided by 2 square root of x minus 2, all divided by x minus 2. So this is getting to be kind of a mess, but we're going to clean it up now. So this becomes 2x minus 4 minus x plus 1. So all right, so 2x minus x is 1x, and then negative 4 plus 1 is negative 3, all over 2 square root of x minus 2, and then let's just multiply this by 1 over x minus 2. So now we can see that the square root of x minus 2's cancel, and we're left with x minus 3 on top and then 2 times the quantity x plus 1 times x minus 2 on the bottom. See if that's actually correct. Something's gone badly awry. Minus 4. Ah, yeah, that's what happened. It's minus the whole x plus 1. It's like an algebra 1 mistake I just made. Okay, so that makes this on top x, 2x minus x, and then we've got negative 4 minus 1 is negative 5. And then that still cancels, and I think we've got it now. Let's see. X minus 5 over 2, x plus 1, x minus 2. Okay. A giant mess, right? Okay. Here's a new way of doing it. Let's take this original function and go, okay, y equals natural log of x plus 1 over the square root of x minus 2. Now, instead of just simply going for it on the derivative, what we're going to do is we're going to simplify the log before we take the derivative. So what we have is y equals natural log of x plus 1 minus natural log of the square root of x minus 2. Remember that rule from Algebra 2? You just go natural log of a over b equals natural log a minus natural log b. Now, one more thing we can do is take the exponent here and put it down in front. So y equals natural log of x plus 1 minus 1/2 natural log of x minus 2. Okay, now it's a piece of cake. Now let's take the derivative of this. So we go, okay, dy dx equals derivative of natural log x plus 1 is just 1 over x plus 1 times the derivative of the inside, which is just 1. That's handy. Then minus 1/2 times 1 over x minus 2. And then derivative of x minus 2 is just 1. That's it, game over. Now notice, if I want to, I can make this 1 over, we need common denominators. So let's just go through this real quick, just so you can see it actually does work. 1 over x plus 1 minus 1 over 2 times x minus 2. Okay, so common denominator is going to be x plus 1 times 2 times x minus 2. Now, what did I multiply the first fraction by? 2 times x minus 2. What did I multiply the second fraction by? X plus 1. And there we are with this exact thing right here. So this ends up equaling 2x minus x is just x. Minus 4 minus 1 is going to be minus 5 all over 2 times x plus 1 times x minus 2. So, the moral of the story is here, if you simplify your logarithm before you take the derivative, life could be much simpler for you. Simplify? Yes, simplify. Okay, so we've basically seen the benefit of something we call logarithmic differentiation, and we're going to do that in just one more example problem. Oh no, I guess we're going to do it right now. Okay, so logarithmic differentiation is what you need to do when your exponent is a variable. Now notice if I have y equals x squared and I want dy dx, let's make it x cubed. Then I go dy dx equals 3x squared. That's the power rule. I take the exponent down in front and then just drop it by 1. This only works when the exponent is a constant. If the exponent is a variable, like let's say I say y equals x to the x, then you go dy dx equals x times x to the x minus 1. This is absolutely false because, well, because basically this is just going to be x times x to the x minus 1 would be x to the x again. And that is absolutely incorrect. So never do that, ever, in your life, or else bad things could happen. Wait, bad things could happen. Okay. All right, so how do we actually do this? Well, the way we're going to do it is we're going to take the natural log of both sides of the equation. That's automatic. You do that every single time that you see the exponent of a variable. Take the natural log of both sides. Not log base anything, but log base e. So, natural log of y equals natural log of x to the square root of x. Okay, that's handy. Because what do we do with the square root of x? We bring it down in front. That's the whole reason we took natural log in the first place. So I have natural log y equals square root of x times natural log x. All right, now it's time to take the derivative of both sides. So what's the derivative of natural log y? Of course, we need to get this all ready. Okay, so we take the derivative of natural log y and you get 1 over y. And then, of course, you need to take the derivative because it's the chain rule. Okay, so times the derivative of the inside. Now, this equals the derivative of the right. Now, derivative of the right, we have the product rule. So we have to go first times derivative of the second. Now, what's the derivative of natural log x? It's just 1 over x. And there is no chain rule because x is not a function, it's a variable. Then, first times derivative of the second plus second times derivative of the first. Okay, now let's clean this thing up. So we say 1 over y dy dx equals, now the square root of x over x is just going to be 1 over the square root of x. Because if I multiply by square root of x over square root of x, well, let's just do that so you see this. So square root of x over x times square root of x over square root of x makes x. No, wait, let's just do this. This is going to be, this will be a simpler way to do it. X to the 1/2 times x to the -1. Okay, then plus natural log x over 2 square root of x. Okay, so now we've got 1 over y dy dx equals, add the exponents, you get -1. So this is x, or -1/2. So we get x to the -1/2, which is 1 over square root of x, plus natural log x over 2 square root of x. So common denominators makes this 1 over y times dy dx equals 2 plus natural log x all over 2 square root of x. Okay, the only other thing we do is multiply both sides by y to get dy dx alone. So that means dy dx equals y times 2 plus natural log x over 2 square root of x. Well, we don't want to leave the y in the answer, so we just say dy dx equals, well, what does y equal? It equals x to the square root of x. Times the 2 plus natural log x over 2 square root of x. That's it, game over. Let's see if that's actually what the book came up with. Yeah, that's the same thing the book came up with. Now, notice example 7 is going to show you this same technique, and it's going to make your life a lot simpler. Let's just do that real quick. So we've got y equals x to the 3/4 times square root of x squared plus 1 divided by 3x plus 2 to the 5th. All right, now, if I decide to do this by just muscling out the product rule and the chain rule, notice the top I have a product, the bottom I have I've got a quotient, and I've got the chain rule and the whole thing, and it would just be a giant mess. Watch how simple it is with the logarithmic differentiation. I just go natural log y equals natural log of x to the 3/4 times square root of x squared plus 1 all over 3x plus 2 to the 5th. Always the first step in logarithmic differentiation. Just take the log of both sides. Now, I'm going to use my properties of logarithms. So good thing you guys had an excellent Algebra 2 teacher. So we go natural log y equals natural log of this fraction. That means we've got natural log of x to the 3/4 plus natural log of the square root of x squared plus 1 minus natural log of 3x plus 2 to the 5th. All right, now let's take the exponents down in front. So natural log y equals 3/4 natural log x plus 1/2 natural log x squared plus 1 minus 5 natural log of 3x plus 2. All right, now take the derivative of both sides. Derivative of natural log y, you're getting used to this now. This is just going to be 1 over y times the derivative of y. So it's going to be, let's just do it like this. 1 over y dy dx equals the derivative of the first chunk is just 3/4 times 1 over x. Derivative of natural log x, 1 over x. Derivative of 1/2 natural log x squared plus 1 is going to be 1 over x squared plus 1 times the derivative of the inside. Chain rule, of course. Then minus 5 times 1 over 3x plus 2 times the derivative of the inside, which is 3. Okay, so we just clean this thing up, and so 1 over y dy dx equals 3 over 4x plus 1 over 2 times quantity x squared plus 1. Oh, rats, I forgot the 2x. Okay. So that means the 2's cancel and I'm just left with x. Then minus 15 over 3x plus 2. Now, the only thing we have left to do is multiply both sides by y. What's y? Well, in terms of x, it's this big mess up here. So that's all we have to do is go dy dx equals x to the 3/4 times square root of x squared plus 1 divided by 3x plus 2 to the 5th times 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. And you know, we actually didn't need brackets. We can just stick with parentheses. Bam! That's it, game over. So basically it makes a lot more sense to take the natural log of both sides when you have a huge mess like that. Then you can split it up into bite-sized chunks and it's a lot easier to take the derivative of each bite-sized chunk. That's it. Have fun with these.